Hi, this talk is called The Rise and Fall of Redux, and the goal of the talk will be to share a history of Redux and understand how it came to be, why did it rise in popularity so quickly, and why it's no longer popular today. And if you're looking at a code base that was written in maybe 2015 or 2017 that heavily uses Redux, and although you might know the basics of Redux, you might not know the decisions that were being made at the time, what led to these decisions, and why we're in the state we're in today. So that's the goal of the talk. We'll also dive into the Elm architecture a little bit and also share some clips of interviews with Dan Abramov. So let's dive in. So the first step is going to be understanding the environment that Redux was born in. And that environment was largely around MVC. MVC was the status quo, was the standard architecture for front-end applications, front-end frameworks. And so example would be like Angular, and it might have been called MVVM or MV star at the time, but this was the basic idea. You had models, views, and controllers. And I was heavily using AngularJS at the time, and I remember having this problem where as my application were to grow, the complexity would grow exponentially. Every view could update every model and vice versa, and it became really hard to keep the data flow in my head, understand state. As well as when bugs were happening, it was like, well, it could be anywhere. It could be in any file. It could be caused by some implicit render. Like, for example, maybe a view was rendering that triggered other models to update, and that triggered other views to update, and had many renders and re-renders like right away. Unlike React, for example, React has like a one render, and then it might cause another render, but there's no like nested renders inside of each other. So then Facebook created this Flux architecture, and the goal was to say, hey, let's create something that's going to be easier for us to reason about, because there was a problem in Messenger.com codebase where you would have this chat message, this chat like a notification that you had an unread message, although everything was read when you opened it. And this bug was something that would be solved and then come up again, and then solved and come up again. And until they used the Flux architecture in Messenger.com, that was when it was solved once and for all. And the reason for this is because you have ability to really reason about your application state, the flow of your data. And if you want to learn more about that, you can watch the talk. There's a link in the bottom left corner. So this was the problem at the time. Like, people were really trying to deal with state, and AngularJS was very popular at the time. React was created in 2013, so it was like fairly new at this time, 2014. And yeah, people were fairly new. I was definitely new in the front-end application space at the time, so I didn't really know of React at the time, and I didn't even know what Flux was at the time too. But from what I hear, Flux was kind of hard to understand. And not only that, although Facebook created Flux, many implementations of Flux existed because the community wanted to tweak different things about it, and so there wasn't one single Flux architecture or library. It was many. And so I can imagine it would be really, really hard to understand why to even do this. Although if you look at this now, we can see I have the word action over here, and dispatcher and store, and that seems like Redux. But the difference here is that in the Flux architecture, you can have many stores. And of course, you would have many stores. React is like a local state paradigm, and Redux was like a single store global state paradigm. We'll dive into that a little later, but for now, let's look at where did Redux come from. And here we'll take a look at two different clips of this Software Engineering Daily podcast interviewing Dan Abramov. Let's dive in.
The rest of that story is that I was hesitant whether to open source it in the beginning, not because I'm a greedy person, but because I wasn't sure that I have something to show. But I was afraid that I wouldn't be able to make it in time for the conference, and I wanted some help with it. So that's why I open sourced it. And it was a very rough prototype at the moment. It was dependent on React. It was not with the Redux that you know now. Anyway, it was just a proof of concept for how you can hot reload I'm interested in hot reloading, as you probably know. So my main concern was, how do you hot reload the mutation logic inside Flux stores? Because I didn't really want to create a Flux framework in the beginning. I tried to use existing ones, but none of them handled hot reloading. Because anytime you change the code, it's going to reevaluate. And if you have a store with local state, is going to wipe away that local state. If you reevaluate the new version of the store, it doesn't have that local state. So I was trying to push mutations to the edge of the applications, to push them into the framework. So all you write is declarative code saying how to change the stuff. And this declarative code can be hot replaced, just like React components can be hot replaced, because they are just descriptions. They're not actual DOM.
And if developers are coming from a world where they've mostly used Flux, what do they need to know about Redux?
Well, I'd say they need to know that it's simpler. And I don't mean to brag or something, but I actually realized that it's very similar to Elm architecture, and that's a very good thing, because Elm was created by a super smart person, by Evan, who thought about it a lot, and I'm just copying the parts that make sense for
what
JavaScript.
Is
Elm?
And we're back. Well, I found it interesting that Dan Abramov said that the inspiration for Redux was getting hot modular reloading working, and that the ideas of Redux came from the Elm architecture. So what is Elm? Let's dive into it a little bit. So one, Elm has 100% immutable data structures. Why is that important? Well, imagine if you have a language that cannot do any mutation, you need some way to update your state, and the Elm architecture is one such way. So what is the Elm architecture? It's the same as Redux. You have these, a store that you dispatch actions to, and find a way to, like a reducer would update state. And this way, you're not doing any mutation directly, but the framework, the runtime, is going to handle those, mutations for you, so that you don't have to worry about them, and you can forbid a mutation in the language level. And that makes sense, by the way, for when you're using a Redux reducer, why you are returning new state, not doing any mutation. It's coming from Elm. So this is like the reason why. So Elm uses 100% global state. There's no concept of local state in the Elm architecture. And in Redux, you might have the question of, hey, should I put this in the global store? Should I put this in local state? But there's no such question in Elm, because there's no other option. There's just the global state. And you might wonder, well, how is that possible? Doesn't Elm have performance problems if that's the case? Like when you're doing all these re-rendering from the top level, you're probably going to get all these, for large applications, you're going to see some performance problems. And no, the reason is why is because Elm has concurrent rendering since version 0.15, which is around 2015. And so we never saw this problem in Elm, but we do in Redux when, for example, you put too much state in global store and then you have a large application. I've seen so many performance problems as a result. And the solution in React is to put the state as local as possible, as low in the component tree as possible, so that you avoid rendering too much. Let's take a look at this little excerpt over here. So the seeds of this are obvious in my thesis. Oops. And the thesis was Evan's senior thesis. Evan was the creator of Elmlang, and in his senior thesis, this was his project. But the wheels really started turning on this in Elm 0.15 when tasks were introduced. That release also introduced a scheduler that was able to switch between work whenever it wanted, kind of like React 18 today. Elm 0.17 improves the scheduler quite significantly, taking some basic insights from the Beam VM used by Erlang and Elixir. So of course, some ideas were translated here as well. And the Elm architecture has no boilerplate. Let's dive into an example, a simple example over here to understand this. So here's a counter, this is the current state. I have these buttons to dispatch actions. And let's look at this program and understand it in terms of React terminology. So here I have a model, and this is the equivalent of a store in Redux. I have types as well in Elm. This is a typed language. The type of your store is going to be int, and the initial state will be 0. Over here we have actions, so they're called messages in Elm. And I have two actions. One is the increment, and the other is a decrement. They could take arguments. There's like much more you can do here. This is a simple example. This is like, imagine an action with no payload. Maybe like the payload could have been like 2, but there's no payload here. And this is our reducer. So here's an update function, takes in the current action, the current state, switches on the action, and handles the new state based on what the current action is. So for example, if I come and say like, hey, you know what, there's going to be another action called reset, and I go ahead and compile this, we're going to get a helpful error message over here that says, hey, so this case is like a switch in JavaScript, does not have all the branches, does not have branches for all possibilities. So here's the code we saw earlier, and here it's missing reset. So of course this is really nice. Like the compiler tells you when you're missing, you're not handling all the cases here. So this is really, really nice. Very ergonomic language to use. Error messages are super helpful, and you get these guarantees that you simply cannot get in JavaScript. So how do I handle this? I go ahead and add this over here. And I can say, you know what, when I reset, I'm going to return 0, which is the new state, right? I don't have to care about what the model state is or what the current state is. I just care about resetting to 0. And over here we have a view function, and this is kind of like JSX, where this is the component name, this is the attributes, and this is the children. Of course, without the pretty syntax with the angle brackets and that kind of stuff. But it's the same idea. And you can see over here, there's no such thing as like, oh, I'm dispatching something, or I have these like action creators and all that stuff. My action creator was just here. I just typed it, and this is both a type and a value, so I can use it inside of here. Okay, I just say on click over here, I'm going to dispatch the reset action and reset to 0. This is going to be the text I see over here. Let's go run this, and I can change the counter state and reset it to 0 and etc. Right? So it's very ergonomic language, very nice to use, really enjoyable. But compare that with Redux, and I have this idea of, okay, I got boilerplate to set up. I have these action creators. I have these reducers in different files. It's more than one file to use Redux, in the typical idiomatic way. So when I was coming into Elm, I didn't like Redux actually, because when I saw Elm, I said, oh, I actually preferred that rather than the translated version of this into JavaScript, and was actually surprised myself that Redux got so popular. But later in the talk we'll find out why it got so popular. So on translation, so we saw that the idea in Elm was translated, and of course, like many ideas in programming, are translated across different languages, different frameworks. So React itself was a translated idea. Originally, Jordan Walk created a React in SML, which is a language like OCaml, and later created ReasonML, which was a syntax for OCaml. So it's the same language, actually OCaml. And later I used ReasonML, which we'll talk about some stories about that later. So this idea that translations sometimes are okay, sometimes they're more complex than they are in their source. Kind of like a joke where you would like say in the source language, but then you translate it to another language, and the joke becomes not funny, right? It's like hard to understand why it's funny. It's just so different, right? And so yeah, this is something interesting to know about Redux, that it's a translation from Elm. And the big difference between the Elm architecture and Redux is that Elm is a global state paradigm, and Redux is local state. So they're fundamentally different, and this is, in my opinion, why Redux is not popular today. We'll get into that a little bit more. So why did the community adopt it at the time? So remember that in 2015, we had Flux and MVC, and many models in either example. And Redux had just a single store, a single model. And just worrying about a single model was like, wow, that's a breath of fresh air. I don't have to worry about all these different potentially duplicated data across all these different models, or how do they all combine together to create the total application state. I just have one model to worry about. That's fantastic, right? And Redux had super amazing docs that made it really easy to get started. Whereas Flux, you had like all these different options to choose from and various levels of quality of docs. So Redux was like clearly the choice to go to with that. Of course, simpler than Flux because you had just one model instead of many. Great tagline, of course, for predictable state container. This was a big one over here. So if I dispatch one action, I can have many reducers listen for the action and update the pieces of state that it cares about, which was very nice because if you wanted to, for example, we'll talk about later in a couple of points, if you want to understand, like if you're onboarding to a new application and you want to kind of understand how the application works, you can just look at, like, pick an action to follow and follow it through the code base to understand how it works. Of course, recording or replaying changes made it very, very helpful to debug issues. But, like, for example, let's say if you were to have a bug in production and you somehow sent the list of like all the actions that were dispatched, that would be, you can easily replay them later on and understand exactly the state that the user was in when they found the bug. Also, this is like something that is not really. There's in my mind, this is like one big reason why global state is such a nice thing, which is it's easier to maintain as business requirements change. So, for example, if you are really careful about putting all your state as low in the componentry as possible, to co-locate state as much as possible for performance reasons, and then business requirements change, you might be forced to hoist up some state, and that's some maintenance work over there. You may forget to push state further down when requirements change, so there might be state too high up. And doing this is not a problem if you're saying, hey, listen, everything's global and it's only ever going to be global. Well, it's really nice to deal with as application and business requirements change. And this is what I talked about earlier, which is, hey, if you're new on the team and you want to understand the code base, you can trace actions very easily across the entire code base and see how they're handled and get a sense of how the application is working and understand, like, hey, this piece of data is changed, this piece of state is changing. How can it change? I know exactly what place it can change. There's one place to go. And lastly, this was something that's relevant in those days, but no longer today. React's context API was experimental, meaning that it would change without warning. So it was not stable, of course. And Redux was effectively a stable API for context. Every time context would change, the new version of Redux would handle that internally, and we wouldn't have to worry about that. Of course, Redux used, like Redux, I think it's React Redux, used the context API behind the scenes and handled those things for us, and so we don't have to really worry about it. So this is going to be like one of the most favorite parts of the talk for me, which is about like my experiences in ReasonML world, talking to folks like Jordan Walk and Cheng Liu, who Jordan Walk created the ReasonML language, of course React as well, and Cheng Liu was a core maintainer, a core team member of the ReasonML team at Facebook. And listening to some of these conversations, reading them, was really, really eye-opening for me. The reason why is because I had the impression at the time in 2015, 2016, 2017 that if you're not using Redux and you're using React, then you're not doing something important. You're not doing an enterprise application. I mean, like you pretty much have to be using Redux if you want to be considered a React developer. And so listening to these conversations was like, wow, really eye-opening. Let's read them. So I'm going to start from here. So this is Cheng Liu. He's one of the core team members for the ReasonML team. We currently don't have plan to bind to Redux and other fluxes. We don't think it's necessary in Reason. So ReasonML is the language. In the same way, Redux, being inspired by the Elm architecture, isn't a proper library in Elm, right? So we talked about that before, that Elm the Elm architecture is not a library. It's like just language features. And in the same way, ReasonML, another statically typed language, it's the same as OCaml, doesn't need a library for those features to exist. That said, I'm sure people will bind to Redux anyway, but I'm hesitating to encourage it. I've given you the link above so that you can try out and see for yourself. But see how we've killed prop types, default props, reactchildren.clone, and the rest through simple language level features. And I'll link in the description a talk that Cheng Lu did about bringing these tooling and libraries as much as possible into the language level itself, and how beneficial that is for application maintainers dealing with all these complexity. And Cheng Lu worked on Messenger.com, and Messenger.com, of course, came up with the whole concept of Flux in the first place. So it's very, very interesting to hear this, that from the same company, the same team, different language, Flux is not necessary. Okay, very interesting. Ricky Vedder, too, also worked on Messenger.com. I'm personally not sure what the few extra layers of indirection and the meta churn of learning and tooling setup of Flux gave us in return, but I'm summoning Ricky to give a less biased perspective. Don't forget that we have JSX punning, just like regular camel function label punning. You can cram a bit more props into your components before reaching for extra tree data management methods. So punning is like, in ESX, like JavaScript, you have a object with a key and a value of the same name. You don't have to do the key : value. You can just say the key, and it puns. Same idea with React props in OCaml and ReasonML. You can just say that you don't have to do like prop name equals prop value. You just say prop, and that's it. So passing props was more ergonomic in ReasonML. Ricky Vedder said, we haven't done any binding to Flux implementations yet because we haven't found the need for it. Punning and partially applied components, so currying is the feature here, are both making it a really easy to work without. That doesn't mean we won't adopt either a library or a pattern if it becomes necessary easier. We are still relatively early in this journey, 2017. Right. So very, very eye-opening for me, very interesting. Let's look at another example of this. So this is a person who's new to the community, talking to Jordan Walk and Cheng Lu. Awesome. Just quickly tried converting JS props from React Router and Redux. Seems to work fine. Also, before I sign up for the night, to support some usage of JS higher order components like Redux's Connect, I got a function to hook blah, 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 blah. Got a gist of what you mean. So Cheng Lu says, hey, I recommend you to try passing props as much as possible before going to Redux. The contexts have changed. Among other things, we got props punning. Passing props is a less tedious than in JSX. Jordan Walker agrees, though we did remove spread, saying that was a performance pitfall anyways. And Cheng Lu was saying, hey, removing props spreading might actually increase the viability of props passing, because now we're not overpassing out of temporary convenience that we pay for in a month, which we then use as an argument to justify switching to Flux. Obviously very opinionated here. Heck, I'd use vanilla functions much less and prefer some arbitrary paradigms too if everyone overpassed data to functions all the time. Great point. I have seen spread get out of hand, right? So super interesting. This was mind-blowing for me at the time. I remember thinking hey, the community is saying you got to do X, and if you don't do X, then you're not a real React developer. But and over here, the folks who created React, the folks who created ReasonML, working at Facebook, using it on Messenger.com, are not doing that, which is mind-blowing to me. So what do we do instead? So we're here now. Redux is no longer the most popular state management library, and let's hear from Dan Abramov to answer that.
That's fair.
My second question for you is, there's this lovely library that is often used with React. You may know of it. It's called Redux. When
Heard about it.
should I use it in my React project?
Well, if the team is already using it, that seems like a reasonable reason to keep using it. Other than that, I don't really know. Like, um, I think I think it's mostly a matter of convention. Like if you
Hmm.
work with people who already know it well, like, or if it's like in your requirements that it has to be implemented with Redux, I think it kind of makes sense. Um, if you like, I kind of think of Redux as the thing where you put something that you don't know where to put, and I think I would kind of look for better places to put things. Which I guess it doesn't answer your question, but I would like first, like maybe like Redux can be like the last option. If I don't know where to put something, then I put it there. But first I would explore, okay, like, is this some kind of like server data? Then like maybe it needs to live in some cache that is like purposefully designed for holding server data. Or like if it is some kind of UI, like if you imagine like two pieces of UI that use the same data, like you probably want to think about, do I want them to be in sync with each other? So like if I render the same component twice, do I want, for example, type in a comment in a post component, and like there's the same post component for some reason on the same page? Do I want what I type to appear there? And like if you don't, which I think you usually don't, then it should be local state, even if it's kind of hoisted up. But in some cases, you do want that data to be shared, but then that usually has to do with like things that don't actually live on your computer, right? Like things that are on the network. And then I think for those, there's usually like better solutions. But if you don't know where to put anything, where to put a piece of data, and like you've run out of ideas, then I think like sure, like you can put it there.
Okay, so if you're starting a new project today, you would only use Redux if you had a piece of data where you could not figure out where to put it anywhere else. Like Redux is the last place you're putting it, it sounds like.
Yeah, and maybe I wouldn't even use it then. But yeah.
Okay, what are you using instead? What should I like? Are you designing your own cache? Is there another library you like better?
I think it depends on the use case, right?
Hmm.
Like what is the use case you're thinking of? Because like for something like server, like data coming from the server, which I think in a lot of cases that's what people want to use it for. Like I would use like a cache like I don't know, like React Query or like Relay or Apollo or whatever people use these days. And then for things that are kind of local, like I think usually that would just be a local state, maybe hosted at the top of the app. But I would think like it's some kind of local state.
And if it's hoisted at the top, do you like to use context for that?
Yeah, sure.
Okay.
And we're back. So I think there's two main takeaways I want to talk about here. One is that global state is going to be mostly problematic in React. Let's say if you're not using React 18, you don't have concurrent rendering, you're going to have performance problems if you're using too much global state. And this is true whether you're using Redux or context or any other sort of global state that will cause a large part of the application to re-render too often, more often than it could be otherwise, because React is kind of built for local state as low in the componentry as possible. Which will, in the resource, there's the next slide over here for resources. There's a blog post by Kent C. Dodds that talks about how state collocation will make your applications faster. Really good read there. And then the second takeaway is, if you're feeling like you don't get Redux, like it doesn't make sense now looking back, like if you're let's say you're working on the back end for the last few years and you're coming back to the front end and you're looking at the code bases and you're like, what am I missing? What is a key piece of information I'm missing that would make me say like, oh, now I get why things are the way it is. I hope this helps. I would suggest that the thing is just a bunch of peer pressure at the time to kind of like scare people in a way in order to use Redux. Like, hey, if you're not using Redux, then you're not a real React developer. That kind of thing. And that faded away. I think that's gone. So I guess that's good. But at the same time, we did learn a lot of things in the time, and it's not like I'm not suggesting like Redux was wrong in any way. Like the only thing that for me was problematic is the idea of, hey, if you're gonna use global state, use something that's built for global state. But if you're using React, use local state. That's pretty much the only problem I had with Redux. And then the other problem was that if you're going to do that, like find a maybe like compared to the Elm experience, it was so much nicer over there that I would be more inclined to do something like an Elm language rather than using the translation. And then maybe the last takeaway is like, if you're gonna want to understand the sources, if you want to understand these concepts, like as they come up in the future, let's say some new concept, whatever it's called, it's likely gonna be a translation from something else. And so the more languages you're exposed to, the easier it'll be to understand the new stuff coming out, because Redux is not a new thing. React wasn't a new thing. The concurrent rendering, the scheduler, is not a new thing. That's been around since the 80s with Erlang. So the more you're exposed to these kinds of things, the easier it'll be to understand these new stuff and feel like you're not missing some big piece of thing. And the last slide over here is going to be a list of resources. I'll put these in the description as well. Make sure people can click on these links if there's anyone that wants to dive further. Thank you.